All right, good morning, friends. It's great to see you all. It's an honor for me to be here and speak to you this morning. So I had to pick a title before I had fully decided what exactly I was going to talk about, because Garrett was being a responsible chair and nagging me to tell him what my title was. So I thought the alliteration was cute, but maybe it's a little bit too frivolous. So perhaps a better title would be this. The joy of building functional languages. So I want to take you back to ancient history. So the year is 1999. I was 17 years old. I had just learned Perl, and I thought that regular expressions were the best thing since frosted mini wheats. And I decided that the obvious thing to do with my newfound string manipulation powers was to write a programming language. The language I decided to build, I don't remember why exactly, but a language that was oriented around the evaluation of set expressions. So it had, set literals, set comprehensions, that sort of thing. The source code is lost. I don't remember what I named it. Setlang is just a stand-in. I didn't write it in a functional style, or any style at all, really. I didn't know about parsing. I didn't know about ASTs, or type systems, or compositional interpreters. I definitely had no idea at the time that others had already done the same thing several decades ago. But none of that mattered. What I do remember is simply being intoxicated with the idea of being able to create my own language, right? This joy of being able to create not just some static artifact, but a whole new way of expressing myself. So, why am I telling you this story? I don't tell it to boast about how young I was when I did that. I certainly don't mean to imply that you have to start programming as a teenager in order to be successful. That's obviously not true. I'm very aware of the unusual privilege it was for me to have the resources and opportunity to do that. And I'm thankful for the people and circumstances that made that possible. Rather, I tell you this story because it turned out to be the first in a long line of similar experiences. Many of the projects that I'm most proud of, the ones that I've learned the most from, that have brought me the most joy, that have created the most community, are related in one way or another to building languages. And you'd think at this point that maybe that would be obvious to me, but I actually only realized this, a few weeks ago as I was brainstorming for what I was going to talk about today. So maybe I'm just weird. Certainly I am. We're all weird in our own unique ways, but I don't think I'm weird in this. So my goal today is simply to inspire you with the joy of building languages. So maybe some of you work on some kind of language implementation for your job. In that case, I hope to just remind you of taking joy in your work. Or perhaps inspire you to build some toy languages on the side just for fun, instead of just only doing it for work. And maybe some of you have never implemented your own language before, or maybe some of you have, but it was a long time ago, and I hope to inspire you as well. Okay, by the way, as a teacher, I hate the idea of leaving all the questions to the end. So please, if you have questions, you can just interrupt me and ask your questions. Probably the AV team would be happy if you did that, if you came up and asked using the microphone here. But you can also ask questions in the Discord channel. So in the ICFP Discord, if you go down and you find Haskell, and then under there's a conversation for this talk. I have that open on my phone right here. So if you put something in there, I will see that. So it could be questions, comments, jokes, whatever. And if it's appropriate, I'll respond. Or you can just put a joke in there for other people to laugh at, and it's fine. Okay. So let me tell you more about my personal history of building languages. So in 2001, or thereabouts, I discovered this language called context-free art. Has anyone else heard of this language before? A few people. Okay, Joaquim has heard of it. Yeah. So this is it's a language for generating images with context-free grammars, where the terminals are not strings, but they're shapes. And you can apply various transformations and attributes and things like that. And by the way, this still exists. It's super fun, and you should definitely go try it out, because it's very easy to make really cool looking images from just a few lines of code. So I started playing with this, and it didn't have a feature that I wanted. Namely, I think it was being able to choose between different matching rules with a weighted random choice. And so, so I added that feature. And it wasn't a huge change. It was maybe, I don't know, 30 lines of code or something. But again, that feeling of being able to imagine a new way of expressing myself and then just bring that way into existence, that was an incredible feeling. And incidentally, this was actually my first open source contribution. And turns out, 23 years later, my name is still in a comment in the source code. This is a screenshot from 2 days ago. I went to the source code on GitHub, and I found, now the code is unrecognizable. I didn't write that code. It's been changed since I wrote it, but I thought that was really cool. So then later in college, probably around 2002, I think, I wrote a ray tracer as a project for my graphics class. I named the ray tracer Photizon. The name is ancient Greek, by the way, and if you enjoy nerding out about those kinds of languages too, you can ask me about it later. So the ray tracer we were supposed to write supported only a very simple scene description language that had several different kinds of primitives and transformations and things, and it was just like a big list of primitives, basically. But and so I think this is the scene that was provided, by my professor as sort of an example. And it looks a little bit complicated, but if you look, it's really only got like 4 primitives, and then there's some mirrors, and it's just, it's not actually that complex of a scene. But I wanted to render more complex scenes like this. So, of course, I made my own scene description language. And it supported, imports and variables and for loops, and it was really just it just macro expanded these things into the underlying language. And I don't know if you can tell it all, but I had a lot of fun doing that. Okay, does anyone recognize this programming language? It's not brainfuck, no. You're close, but yeah. So this language is called Befunge. It's a truly demented esoteric programming language where the program counter consists of a row, a column, and a direction, and each character is an instruction. And of course, and there's no separate like instruction memory and data memory. It's just it can write over itself. And so I didn't create this language, right? Someone else made this, but my best friend Steve Winslow and I, for some reason, for our winter term project one year, we decided to write a compiler that compiled C into Befunge. Well, a subset of C. I don't remember why we decided to do that, but collaborating intensely with my best friend for a month on this project was a ton of fun, and I learned a lot about parsing and compilers, even though it's not the usual use that those things are put to, but it worked. It was great. So we're now in my personal history, we're now up to about 2007, which is the year that I fell in love with Haskell. It's a fun story. You can feel free to ask me about it sometime, but that's not the point of the talk, so I won't dwell on it. But apparently, while learning Haskell, I must have read several papers about embedded domain-specific languages, because one of the first non-trivial things I did with Haskell in 2008 was to build a pretty clunky EDSL for text adventure games. Yeah, like I said, it's quite clunky, but it worked, and it was very fun. I keep thinking that maybe someday I'll go back to this and rewrite it, but I don't know. It's never it's never managed to make it to the top of my priority list of projects. So then, some of you might know, in a very different vein, I created a Haskell embedded domain-specific language for calculating with combinatorial species. It doesn't matter if you know what those are. Looking back on it now, it's also quite clunky, I think. But mostly, I built it just to help me learn the theory of combinatorial species. And in that, it was spectacularly successful because I ended up writing my entire PhD dissertation about these things. Then I spent the summer of 2010 doing a research internship at Microsoft Research in Cambridge. So this is me punting on the cam with my mother-in-law, my third cousin-in-law, and Celeste the travel bear. And I spent the summer thinking about things, probably about promoting types to kinds, I guess. That paper, I think, came out a year and a half later. As well as I recall, helping implement an overhaul of GHC's constraint solver. So this one is a little bit different because this, of course, is not a language that I created. But I include it because, similarly, I was helping to build a language. And this is probably needless to say, but this was a wonderful experience. I remember everyone, especially Simon and Demetrius Vaitiniadis, being kind and generous, and I learned a ton. Being in Cambridge didn't hurt either. Let's see. So then, in 2008, I made another EDSL. This one for describing and rendering vector graphics. We're probably getting more into territory that many of you have heard of before. But what you may not know is that the version that's on Haskell now is actually the second diagrams library. The one I made in 2008 was clunky and had some pretty severe design limitations. I sort of coded myself into a corner, and I had all these features I wanted to add, and there was just no way to add them. And so eventually I threw it away and spent about a year and a half redesigning and re-implementing it from scratch. And the new, more elegant version was released in 2011, and that is the version that's continued to evolve into what's still in Hackage today. So rewriting that whole EDSL with the more elegant and formal semantic foundation was a very formative experience for me. I remember learning a lot from Connell Elliott about denotational design, and I think I probably went through about 15 or 20 variants, of the API before finally converging on something that felt right. It's still not perfect, but I think it stood the test of time pretty well. And a significant aspect of this project, as opposed to some of the previous ones, right, was that this was my first open source project that actually attracted other contributors. And so this is actually not a complete list. This is the biggest screenshot that would fit on my slide. But there were a few people that became involved with the first version of diagrams kind of early on, and then helped with the rewrite to the second version. And that attracted yet more contributors, right? And there were quite a few years where we had a pretty vibrant virtual community around the development of diagrams. Of, I would say about 5 to 10 people, and some of whom remain my friends to this day. And of course, there was a long tail of people who contributed in smaller ways. It's pretty much died out now, which is fine. I think it's sort of reached. It's at a good place. We just maintain it and make sure it keeps building and people use it. We're not actively adding new features, but that's fine. I moved on to other things. So, but the other really cool thing about this project is just seeing all the ways that other people have been empowered to create really cool stuff with it. So this is just, the stuff that's on this slide is just a tiny sampling. There's lots and lots of other things, but I just picked 4 kind of representative and different examples. And this is a really cool feeling. Not only that I created something that enabled me to express myself, but I created something that empowered others to create and express themselves as well. Okay, so I want to take a little step back, right? So I hope I've convinced you that I, at least, find building languages to be joyful and meaningful. But I don't think I'm the odd one out here, right? So why do I say that? So humans are many things, but according to my faith tradition, there are two primary things that I would say characterize what it is to be human. We are made to be creative, and we're made to be in community. And one of the primary ways that we engage in both of those things is through the use of language. And that's in imitation of God, who created the world by speaking. But you don't have to agree with my faith tradition, right? Regardless of your beliefs, I think it's self-evident that creativity and relationship are at the core of what it means to be human. And if we think back over my experiences building languages that I've shared, I think you'll notice, I sort of noticed three main themes. So one, of course, is creativity, right? So building a language is a creative act. But it's more than that, right? It's creating a new means of being creative and empowering others to create as well. And that empowering others to create naturally overflows into community, right? So building a language often corresponds to building a community, right? I think we've all seen this in various ways, right? And you'll see that, as I gained more experience and built sort of bigger projects, right, that became more and more true, that there started to, there was more community generated around those projects. Right, shared purpose, collaboration, right? Collaboration is just shared creativity. And those are wonderful things for building community. Last but not least, you'll notice how much that I said that I learned from all those projects that I did. I hesitate to include, a love of learning on the same level as creativity and community in terms of sort of what's fundamental to being human. But I think it's a pretty safe assumption that everyone listening to this talk, at least, identifies with a desire for learning and a love of learning, right? So if you really want to become a PL expert, there's no better way than actually designing and implementing languages. And it really makes no difference whether they're just toy little silly languages or industrial strength compilers or anything in between. And just to drive this point home, I know some of you that are teachers might recognize this. This is called Bloom's taxonomy. It categorizes different levels of sort of thinking and learning. And it's a helpful model both for planning and assessing the level at which teachers are asking their students to do things. It's also a helpful model for just self-reflection on your own learning and sort of the strategies that you're using to do that. You can see that creating things, that's the highest level on this taxonomy of learning and thinking. And not only that, right, but engaging at any particular level actually strengthens the levels below it as well, right? And you also don't have to be an expert, at each level before moving on to the next level, right? You can kind of like move around in this taxonomy, right? So another way to put this, right, trying to create is the ultimate form of learning. So from that perspective, right, it's kind of no wonder that I learned a lot from all these projects. Okay, so this is why I keep using the word joy, right? To me, that's not about being happy, although those often go together, right? But joy has to do with flourishing as a human being. And if all of these things, creating, learning, community, are happening, right, I would call that flourishing. I would call that joyful. And not just are these things happening to you individually, right, but that you are enabling and empowering others to experience that sort of flourishing as well. So I want to tell you about two more of my language projects. But for each one, I'm going to specifically highlight some of the ways that they led to creativity, community, and learning for me and for others. So Disco, this was a language that began as a collaboration with Harley Eads at TFPIE, Trends in Functional Programming in Education, I think in 2016. So we were both there, and we started chatting, and we just got very excited about the idea of a language for teaching functional programming and discrete mathematics. And we spent a bunch of time over the next few days sort of hashing out ideas and syntax and semantics, and then since then, I've continued to develop it quite a lot. It's still rough around the edges in some places, but it works great. I use it to teach discrete mathematics, typically to second-year undergraduates. It's designed to be as close as possible to standard mathematical syntax in practice, as opposed to necessarily standard functional programming practice. Right, in order to minimize the degree to which students feel like they're being forced to learn two different languages, the language of mathematics and some programming language. And it both exposes them to functional programming ideas and also gives them sort of a computational playground to help them learn the math that they're learning. This is just some example disco code that I use when teaching students about set comprehensions, coming full circle from that first language that I made. Yeah, designing this language, it required a lot of, it was fun and it required a lot of creativity to design a language that was close to mathematical syntax and practice and also easy for students to use. It led to some very non-traditional choices. And as a result, the type system is actually pretty complicated. So it's got subtyping, it's got qualified polymorphism, it has equirecursive types, and if you're interested in why I made those choices, I'd be happy to talk to you about that later. I still believe those are the right choices, even though it led to a very complicated type system. I had to learn a lot to make that work. I remember spending a whole summer reading papers and just pulling my hair out trying to figure out how to whether this was going to be possible. I specifically learned a lot from actually Isabel's implementation, because Isabel also has some of these same features. And as for community, there were a few outside contributors early on. At this point, it's mostly it's mostly me and a bunch of my students that have been working on this. So there's a lot of students that have used it and then, of course, gone on to help work on the implementation. Two of them are here with me this week. And so, I would say Disco has been sort of indirectly responsible for bringing new students into the functional programming community. And that's something that I'm proud of. Swarm. This is it's a 2D resource gathering and programming game. So this was back in the fall of 2021. I had a sabbatical, and I had a lot of plans for all the different projects I was going to work on over my sabbatical. And about 2 weeks in, I suddenly had the idea for this game, and then I dropped everything else and just worked on that, which was fine. And been working on it ever since, not as intensely as that first few months, but and just to tell you a little bit more about the game, if you haven't seen this before, right? So the little capital Omega symbol in the middle, that's you. You've crash landed on this planet, and the atmosphere is toxic, so you can't go out of your little spaceship. The only thing you can do is to program robots to go out and explore for you. And as they collect resources, you can use those resources to craft devices that allow you to unlock additional programming language features. So you have to it really is a programming game. You have to figure out how to accomplish some tasks using the limited language features available to you so that you can unlock additional features and then write more sophisticated programs, set up automation and things like that. This really, of course, like I said, this started as just a silly fun. I didn't really think it was gonna, I thought it'd be fun to make a programming game because I like programming, but I didn't expect that it was going to be as professionally fruitful as it has been. So I've actually learned a ton from building this game. So I've learned about CESK machines, about effects typing systems, also just things from game programming, like how games deal with variable frame rates and all those sorts of things. It's attracted a small but thriving developer community. I think, right, I mean, there's even been, some pull requests, like, yesterday there was a pull request. And I hope one day it will also attract a community of sort of player developers who are not necessarily hacking on the implementation of the game itself, but creating, levels and scenarios and stuff like that to share. It's definitely, so you're welcome to try it out. I would love to have people's feedback on this. It's definitely missing some big features such as saving your game. Which, to be fair, saving your game is complicated when your game consists of lots of robots that are running programs and you have to like stop the world and save their current abstract machine state, but anyway, we'll get there. I know how to do it in theory, just haven't done it yet.
I guess you invited us to ask silly questions during the talk, so maybe I'll start so people.
Yeah, sure.
Did you start this before or after Factorio started to decrease productivity among the people here?
I don't know. It's a good question.
Or did you know about Factorio?
I did.
What was the inspiration for the game?
Yeah, well, I had an idea that I wanted to build some kind of game where you were required to program in order to like explore the world, and I had tried designing this multiple times and sort of gotten bogged down, and the language was too complicated, or it just didn't seem like it'd be fun enough. And the thing that suddenly sparked that I felt like I had the right idea was just this conceit of that you have to explore and collect resources in order to unlock new programming language features. So that was sort of the genesis of it. I mean, I certainly was generally inspired by like Factorio and Minecraft, and it's sort of like a combination of Factorio and Minecraft and Carell the robot, I guess. So I had played Factorio a little bit before this, but yeah.
Okay, thanks.
Mm-hmm. Yeah, and Gergo asked a question on Discord. Would someone interested in finding out more about implementing a Haskell-like type system similarly be able to learn from the GHC code base, or would they just drown? That's a good question. Probably they would drown, I think. It wasn't just like I sat there and just studied the GHC code base. I had, some knowledgeable and generous mentors to help as I was working through this. I remember, trying to make some changes and it wasn't really working, and I went and asked Simon, and he said, oh yes, you just have to make sufficiently vigorously, and then, so we had to like, make -- really I mean it, and then it worked. So things like that I wouldn't have been able to figure out on my own, but I think there's plenty of other things to study if you want to learn more about how to build those kind of type systems that are not as complex as GHC. Yeah.
But if I can just ask a follow-up question, I guess my real question is like, from Isabel, you were able to learn.
Right. Well,
is there any lessons for us?
Right. I didn't learn from the Isabel implementation. I learned from a paper that some of the authors published about it. So.
Okay.
Yeah. I don't think I would have been able to figure out by studying the implementation itself, probably. Yeah.
So, Carl the robot teaches imperative programming, right?
Right.
And I noticed that you have taught the introductory courses. So is Swarm going to teach introductory programming to the next generation of Hendrix
Maybe.
students?
Yeah, I've definitely gotten that question before. And I guess I didn't say anything about the programming language as you might expect, it's not an imperative programming language. It's based on the polymorphic lambda calculus with algebraic data types and recursion. And yes, it has a first-class command monad for imperative programs, but you know, I certainly didn't build it to be an educational tool. Unlike, you know, Disco, I definitely built from first principles as an educational tool. This Swarm I just built because it sounded fun and I wanted to have fun making and playing a game. Could it be useful for education? Certainly. And, you know, definitely, I think there's ideas how that might work. I could imagine someone designing a sequence of little challenge scenarios that sort of introduce. We have like a sequence of tutorials and stuff that introduce the game, but they don't really introduce programming. You kind of already have to know how to program. You already kind of have to know functional programming. I think it'd be hard for someone that doesn't know any functional programming to get into it. But I could imagine a series of challenges that are constructed in such a way that they introduce those things more gently. And I've used it before in my programming languages class. And I'm going to be teaching that again in the spring, and I'm thinking about how I might incorporate it. All right, this is a good time for questions if anyone else has other questions. All right. So I've talked about building languages enough. So let's build one. What I really would love to do would be, you know, just to take suggestions and just like make something completely, you know, spur of the moment. I'm not sure that would work. You know, maybe if we had like 2 hours or something. So what I have is I kind of have an idea, or I have an idea for a language that I've already kind of developed and it kind of works. And so that's kind of the direction that I'm going to start in, but I would love your suggestions and interaction. So you can you know, make suggestions in the Discord or jump up and say things. Also, right, this is the GitHub repository for my keynote, which also, for like the slides and stuff, but it also is where I'm going to be coding this language. So I even am open to pull requests. I don't know exactly how well that's going to work, but we can try it, right? So, you know, be judicious. You know, if you make a pull request that's going to create lots of merge conflicts, I don't really want to deal with merge conflicts in the remaining half an hour, but yeah, I hope we can do something. So here's the idea that I had. It's like, okay, what could we do that would be, you know, fun and something that it was not going to take like, you know, days to build. So the idea that I had was a language oriented around constructing strings, and specifically one in which you can write down descriptions of various you know, popular songs that have repetitive sorts of lyrics. So like, think the 12 Days of Christmas, if you know that song, or the green grass grew all around, or anyway, so that was sort of my idea. And so, you know, we need strings and we need concatenation, but then we also want things like, you know, we have to have some way to count and to do loops and stuff. So if we have like some lambdas and some numbers and some conditionals, some recursion, right, we can sort of build those things. So let's see. So I'm calling this language cats. Bigger, yeah. Let's see. Oh, I don't have. Okay. How's that? Is that good? All right. Yep. So I have a basic just some structure set up. So, you know, I have some libraries that we might need. And there's just blank, you know, so there's a main that has nothing in it, just says cats, and oh, I guess we have natural numbers already. Look at that. All right, so we're well on our way. I'll make this bigger too. All right. So, well, okay, we can leave that for now. Let's make, so I'm making a data type for the terms of our language. So we have natural number literals. I'll make some text literals. I probably need to import data.text. Okay. And probably what I want to do, what I often do, and probably many of you do this too, right? I'll try to get something working as quickly as possible that's just like super simple and dumb, and then we can add features as we go. So I guess we need to write a parser, and we need to write, here's a parser. We need to write an interpreter. We will probably want to write a type checker too, and we'll probably get there. So I don't know, I'm going to write the interpreter first. So we're going to have a type of values. So we'll have vtext text, and we'll probably have vnat integer. And I don't know, we'll do deriving EQ and show. Let's see. So then I'll make an interpreter that takes, eventually it's going to take some kind of environment once we add variables, but for now, we'll just say it takes a term and returns a value, and lambda case, so if we see a t nat n, then we return a v nat n, and if we see a t text t, we're going to return a v text t. Okay. And we need to turn on lambda case. All right. We're almost there. I mean, this is most of it. Okay, so let's write a little parser. Let's see if I can do this on the fly. This is going to be a little scary. So what is it, like text.megaparsec? We probably want that, and we want text.megaparsec.char, text.megaparsec.char.lexer, qualified as L.
You must have done this before.
Yeah, oh, I did. Yeah, this is completely just off the cuff, just totally, yeah. No, like I said, I didn't think that was going to work with the time that we have, so I've practiced. But also, like I said, I'm happy to take suggestions, so, I don't want this just to be me up here coding exactly what I intended the whole time, so. Or questions, of course. So, okay, the way that we make so megaparsec is definitely my favorite parsing library these days. For general purpose parsing, I think it's very nice. So we're going to make let's see. Oh, we have to say like.
Brent, what are the little underlines that going on in the imports and the duplicated stuff up there?
Oh, it's warning me that I haven't used those imports, I think.
Oh, I see.
Yeah, it's suggesting I should delete them, and I said no, I just worked hard to type those. I don't delete them yet. But yeah, it's or it's suggesting that maybe I would just want to say this. So if I click this, it would replace it with. But I'm gonna leave it for now. So let's see. I'm gonna make a type synonym for parser A is and I think it's like parsec void text A, I think. So if I'm recalling correctly, void, that's like that first argument is the type for custom errors. We're not going to have any custom errors, so I just put void. And then text is the type of sort of the input that it's going to parse, and then A, of course, is the result. I guess I could A to reduce this, but I don't know. We got to import data.void. Okay. And then we'll make a space consumer, right? So this is going to be L.space. And I think L.space, let's see. It takes, maybe that's too small to see. It takes a parser for oh no, I see. It's just giving us different. Yeah, so we want to say something like space one, L dot line comment. Wait. I forget. Okay, might have to go look up the documentation. There's some way to, let's see, mega parsec.
Any to any business.
Yeah, I don't know. I was hoping you could tell me. I think it's showing us like different possible types it could have, sort of at different levels of specialization or something, but I have no idea why it would specialize M to any.
Yeah.
That doesn't seem very helpful, but I don't know. It's probably not your fault. It's the language server is doing that or something. All right. Let's look this up. Char Lexer. So yeah, parser for line comments, block comments. Skip line comment. That's, thank you. All right. So L dot skip line comment. There we go. We'll just use this sort of syntax for line comments, and we won't have block comments. Okay. So we can define a few things like lexeme, which is parser text, or sorry, parser A to parser A. Lexeme is L dot lexeme SC. So right, the way that megaparsec exports a bunch of things like, you know, a lexeme parser and a symbol parser and stuff, but you have to parameterize it. It's parameterized by how you want to eat up white space. So just for convenience, we'll define these. So symbol can be, let's see. So this is going to take text and return a parser unit, I believe. Equals L dot symbol SC. All right. Uh-oh. Why is it yelling at me? Parse error. Oh, no. Anyone see what my parse error is? Oh. Maybe it's just confused. I don't know. All right, I think the language server just was confused. Well, yeah, that's not a parse error though, right? Now it's giving me ambiguous empty. Okay, right. So okay, so data.text, we'd really just want like there we go. Okay. Okay. So let's see. Now I want to. Uh-oh. Okay. Oh, I need to overload. Yeah, I need to overload strings. That's right. Okay. Overloaded strings. There we go. All right. Thank you. And what did I do wrong here? What was that?
I think you need to return parts of text.
Oh, okay. Yeah, that's right. Yeah, okay, makes sense. Let's see. So now, okay, now we need to, let's start writing a parse term. It's going to be a parser term. And, well, okay, eventually we're going to want like a, we're going to do like make expression parser. We're going to say parse atom, and we're going to have a little table of operators and stuff. But right now we don't have any operators, so we'll just make an empty table. And then parse atom is going to parse atomic terms such as natural literals and text literals. So parse atom is going to be, so a text literal, let's see, or let's do tnat first. Tnat, oh, we need a, okay, let's see. Natural is a parser integer, which is just, I think it's called L.decimal. Let's see. What was that? Yes, I do. Thank you. What did I, oh. What's it?
Not for symbol,
What was that?
but not for symbol. We've got natural and lexeme, but not symbol.
I have natural and lexeme, but not symbol. What do you mean?
Natural will go to lexeme dollar.
Yeah, so the symbol sort of all.
It's just decimal, that yes.
Say that again. Sorry.
Does lexeme actually take SC or is it just?
No, it doesn't take SC. Like that's already. It's already partially applied to SC up here. Yeah, no, right. I think someone said that, but no, I think we don't need lexeme there because these things like lexeme, symbol, decimal that are provided by megaparsec, right? They're parameterized by this space consumer, and so they're already doing like lexeme kind of. They're parsing a thing and then they're eating up white space afterwards. So I think those are okay. I still don't know why it's highlighting this in red. I don't know. We'll keep going and see what happens. So TNAT decimal, or natural, right? Or we could have a T text, and then we'll make like a, let's see, symbol, this, followed by, it's like many, L dot char literal, and then another quote mark. That should do it. And that char literal.
Decimal doesn't take the SC. So I think you want your lexeme called with L decimal. That's the area.
Say that again.
L decimal doesn't take SC.
Does it not?
No. You want your lexeme with that as the area. Without SC.
Hmm. I don't think so. I think this is. It does. So it says. Yeah, it takes a. It has type parser unit to parser integer. And I think that parser unit that it wants is your space consumer. It's this type checks, I think. Let's see. REPL. Okay, no, it doesn't. Oh, couldn't match type. Oh, right. So we need to like, this gives us a list of chars, so we need to, t dot pack or something like this. Couldn't match type token SR with char. Use of, oh goodness. All right, you're right, I did something wrong here. Oh, now it doesn't type check. Okay, got it. So, but you're right, then we do want to wrap it in lexeme because, yeah, okay, cool. All right, very good. So I practiced this, but you can tell I didn't practice it that well. All right. Cool, so, well, let's see, we can like, I don't know, we can try this out. So we can say, really, let's make a main in just a second. So run parser, parse, atom, 23. I need overloaded strings here too. No instance for show term, of course. All right, we can add that. Deriving, I don't know, show EQ. Cool, it parsed. Woohoo! All right, and then we can also try out hello, and we'll also. So, oh no. What was that? Did I miss a backslash or something? No, so I wanted 2 backslashes here because the L.char literal should parse escape sequences. So I was trying to put an escape sequence in the string.
Does char literal parse the unescaped quotation marks? Or do you want to also escape those quotation marks?
Oh, we have to do something like, yeah, you're right. Because, yeah, char literal here, it's going to eat up that final, yeah. many till, yeah. Something like this. Does that work? Other way around? Oh, okay. Oops. Okay. Like that? Okay. Nope, doesn't like that. Oh, the many till parses it eats up to, okay, great. There we go. There we go, all right. Sweet, it works. Yeah, yeah, no, it is, it really is. Every time I go to write a parser, I'm just like, oh, how does that work again? Yeah, okay. What was that? Oh, right. Well, that's fair.
The symbol reminder you could have used white space, so you probably want char instead of symbol. Because otherwise you are consuming the white space after the pull.
Oh, yep, very good. You're right. Yeah, we don't want to consume, so right now if I just, yeah, so it ate up the spaces after my quote mark, so you're right. But if we change that, oh. I thought I did, oh yeah, I do. Yes, that makes sense. Okay, that's better. Okay, yeah, but we do want the symbol here because we do want it to eat up white space after the closing quote. Okay, so let's go make a little. Yeah, exactly. Let's go make a main, and we're just gonna, let's see. So we're gonna say import cats, and let's see. We'll just say do, file name get args. This is gonna be very ugly, but import system.environment. Okay, and then we're gonna read file name, and then I guess actually we want to use let's see, import data.text.io qualified as t. So we're gonna do t.readFile so we get some text because that's what our parser takes. And then we're gonna say, case run parser parse term file name text of, and if it gives us a left error, we can just for now. Well, there's a what is it like pretty? Oh, I don't know. Whatever. Again, it's going to be ugly, but it doesn't matter. There is a nicer thing we could use for megaparsec to show the error, but probably want that eventually. And if we get a right some term, then we're going to interpret it. And for now, we'll just show the result. Maybe we'll make a pretty printer later. Interp term. Okay, so now if we say.
Maybe put strlen show.
Yeah, you're right. Put print. Yeah. Okay. Oh, and I need to import. Import text.megaparsec. Run parser. Cabal build. Okay, I need. How much time do we have? Not much. Okay, well, that's okay. I thought this would be ambitious. Megaparsec. Okay, so we have less time than I thought. Writing parsers takes longer than you think. Let's at least get concatenation of strings. So what I was thinking is, because string manipulation is the most fundamental thing in this language, right? So string concatenation operator is going to be space. And then, and we'll use, like an @ sign or something for a function application. So let's at least get concatenation working. So let's see, test.cats. So we'll make a little, hello. Right, so I would like this to parse as, a concatenation of these two text literals, and then just, well, let's put a space. All right. So right now, if I say cabal run test.cats. Oh, what? Okay. Okay. Well, and of course, right, we really. Yeah, we should do like this, so that we force it to consume the whole thing. Oh, we don't have. Okay, we need that too. Okay, good. It's a parse error now. And all right, so let's go back here. All right, so we're going to add. So we need application, which is term.
This is concatenation.
What was that? Yeah. So I was going to make. We have function application, and then I'm going to make some constants. So we're going to have like an application operator constant. So which is like a const, and then our const is going to be, well, we're going to have capp for now, deriving EQ show. Okay. And let's see. So for our parser, we can in our table, right? So we're going to have. Let's see, how does this work? It's like infix, so this should be probably left associative. And it'll be something like, well, let's say make bin capp. I think this works. I don't. Maybe someone out there knows the answer to this. I've never known, like, how do you parse, function application or whatever your space operator is. Is this the right way to do it? This always felt like a hack to me, that you say, oh, the syntax for my operator is the empty string, and this seems to work, but I don't know if there's a nicer way to do it. Yeah, I guess you could do it right, like a chain thing. Yeah, that's true. Yeah, have it separate. Yeah, that's true. That makes sense. But this is a nice trick that you can just have it as part of your expression parsing. All right, what does it complain? Well, I haven't defined make bin, of course. Make bin. By the way, Garrett, how much time do I have? I don't know what time this is supposed to end officially.
So I think the coffee break is actually at 10:30.
Oh, okay. Well, we won't go till 10:30, but. Okay. All right. All right. So if you just start leaving if you're done, I guess. No, let's at least get this working. Let's get this working, and then I can show you the one that I made earlier because it's kind of fun because we're not going to get all the way there. But so make bin is going to take let's see, a constant, and it's going. Oh, actually no. I want to do this, and it's going to take AB, and it's going to do tapp of C to tapp of C to A, and tapp that to B. Okay. Let's just make it sure it still builds. Of course, it does not. Okay, we need to. Oh, control mode. Okay, right. You know what? We're just gonna. All right.
You don't want text mega parse instead of that.
It doesn't exist anymore. So all these sort of combinators got moved out of megaparsec into this parser combinator package. Yeah. What is it yelling at me now? Could not expect actual type term. Oh, I see. Because, right, I need to wrap this in a t const. Okay.
Is there a good up-to-date kind of how to write a parser with megaparsec?
Yeah, right. Is there, I don't know. I mean, there's a nice tutorial that I learned from. I don't know if it's up to date. I mean,
Various combinators move to different places.
yeah, I mean, that's not, they're still exactly the same combinators, so it doesn't invalidate any tutorial materials. It just means you have to import them from a different place. Which, maybe the first time you're like, what do you mean it's not in scope, but let's see. All right. Oh, it's non-exhaustive, of course, because yes. So I think,
You should put a pointer to the tutorial in your
okay, yeah, sure, I can. Okay, good. So now, when we do that test file, it parses, but the interpreter crashes because we haven't dealt with application or constants or anything. So let's do that. So if I have, let's see. Okay, so here's what we're going to do. So tconst c, we're going to say interp const c, and we're going to make an interp const that takes a const and gives us a value. And so then interp const is going to be, case, and we have our c app. Well, we're going to need to make a new kind of value for these. So I'm going to make eventually if we added lambdas, we'd have to make like, a closure value, but for these interpreting these constants, I'm just going to make like a literal function value that, and then, oops, c app. Wait, is that? Yeah. vfun. Oh goodness. What do I? Yeah, no, wait.
That's fine. vfun of a lambda x and returns another.
Okay, no. I know. Okay, I know. I got really confused. I know what's going on here. This wasn't supposed to be C. This is supposed to be like C. This is concatenation, right? And the application is a term form, not a. So okay, C cat. And this, okay, so we're going to say, I'm going to make a little with text helper here that's like, if you give it a text to value function, it'll turn it into a value to value function. And it's just going to crash if you give it something other than text, which is why we'd want a type checker, but with text f equals lambda case. If we give it a v text t, we'll just return ft, and otherwise, we'll say error not a text. Okay. And so then I want to say vfun, with text x with text y v text x plus plus y. What was that? Needs to be polymorphic in the, oh, you're right, because, does it? Oh, yeah, you're right. I need a vfun, yeah. That's it, yeah, okay. What was that? More parentheses? Is that enough? Okay. I'm just gonna, where? Oh, you're right. Yeah. They're not strings. Yeah, so t.concat. Okay, yeah. Good. Okay, and then we do need to interpret t-app. So that's, I think, why this is yellow. It's telling us that we haven't handled everything. So if we have a T app, fx, well, we'll say case f of, if it's a v fun, yes, very, thank you. Interp T1 of, if it's a function, we're going to say f applied to interp T2, and otherwise, error, not a function. Okay. What was that? Yeah, oh, yeah, right. I definitely wasn't going to write a lazy language in 30 minutes. Okay. What is it?
Should be append instead of concat.
Oh, not, what was that?
It should be append.
Append. Oh, right. Concat is you take a list and yeah. That's true. Okay. Oh, I think it's just, it wants me to. Okay. Oh, yeah. We can't derive EQ and show anymore now that we have functions in it, so we'll get rid of that. Okay. I don't know. Are we done? I mean, right now I just call show on the values. So as long as we don't get a vfun out. Oh, but right, I see. We had to. Yeah. Okay. Instance show value where show equals. Yeah. Okay. Oh, good. Yeah, that's a good idea. Yes. All right. So deriving show instance show a arrow b where show underscore equals. Okay. That works. All right. Oh, right. C app. So now we can't. Yeah. This is C cat. Yes. Okay. I forgot that was in base. Orphan class instance. Oh no. It's so sad. All right. Yay, it worked. Woohoo. Okay. I've never gotten applause before for concatenating two strings. It's great. Interpolate, yeah, sure, we can do, yeah. So in the next 5 minutes, I'm going to implement recursive, let, and lambdas, and, okay, no. I will show you the one that I made before, so, because it's just fun. I had fun making it, so. So, not yet. So, it's got types, it's got a whole bunch of different constants, and it's got let rec and lambdas and conditionals. Conditional is like, a list of, and blah, blah, parser and the interpreter. Okay, so I don't know how I thought I was going to code all of this in 30 minutes, but, so let me show you some example code. So here's the 12 days of Christmas. So let expressions are just in brackets, and this is a conditional, right? And let's see, what do we have? Oh, here's our for loop. So it takes a number and a function, and as long as n is greater than 0, it calls the function on that number and then calls itself recursively. And so if we run this, let's see. Oh, how am I gonna? Yes. So conditionals, because conditionals are only allowed to return strings, and so if nothing matches, it's just the empty string. Yeah. This is a very sensible thing to do, I think. I mean, yeah, the language is not polymorphic, so like conditionals always return strings, and there was something else that was. Right. Exactly. Yeah. And so. Here. I also, let's see, I made this one. So. It's the Towers of Hanoi. song. Oh yeah, well, that's, so here I could say, how many do you want? 5, okay. I don't know, I had a couple others, like there's, the ats, that's function application. Because, the space is already taken for the more important operation of string concatenation. So we have to use ats. And it turns out that one of the most common failure modes when writing programs in this language is to forget the ats. And then you get very strange error messages that are, it's like, oh, I was expecting an int, but I got something instead. And you're like, what? Oh, because it was trying to concatenate, this function and 5, and it didn't like that. Right.
Well, when you use explicit type applications, you have to use at.
Exactly. Okay, anyway, yeah, there's a few more examples in here, but you know where to find it. So anyway, yeah, thanks for listening. Go forth and build languages, be creative, create community. Thank you.
I am merely disappointed that this does not support data kinds. That's all.
Yeah, not yet. Yeah, check back next week.
I was just reflecting, Brent, on your remark, your sort of almost throwaway remark earlier that building programming languages not only is an exercise in creativity in its own right, but it, if you sort of hit the spot somehow, it gives other people an opportunity to be creative. Mm-hmm. But it's difficult to plan for that, right? Sometimes that works out better than others.
Yeah, that's true.
I think Haskell is a sort of almost like a serendipitous, amazingly, it is, it's let people create things that I never dreamed of when we were originally designing Haskell. But I think it's really difficult to know that you can have that as a goal, but I don't know how to execute on that goal.
Yeah, I mean, I don't either. You're right.
Yeah.
I think just, try a bunch and see what sticks, I guess. But, I mean, there's value in this whether or not your language ends up taking off and enabling other people or not. But
yeah, but there's sort of taking off as in utility. Do people use it for a lot of things? And there's taking off it as in, oh, you've done something that I never dreamt you could possibly have thought. I sometimes think when I look at lens programs, I think in an untyped language,